Good morning, grade 12s. I hope you're all well and had a good weekend. Happy Monday to you. We're going to talk about object-oriented programming now. You've been working with object-oriented programming all the time. Every single item, a label, a panel, is an object. And every object has properties and events. So the properties are like the data, how it is described, and the events is what we can do with it. We can click on anything, we can exit it, we can key down, we can double click, and so on. Those are the events. So objects have properties and events. And you've been working with a form class. It says form is a class. Okay, another word for class is a type, like a data type. And the form itself has its own properties and events. As we know, they're in our object inspector. And so do panels have their own properties and events, and labels have slightly different ones, and edit boxes, as we all know from experience, they have different properties. There's ones that are in others but not in an edit box. So for instance, classes are declared under the word type, as you can see, and we are going to define our own class in object-oriented programming in grade 12. You're going to make your own class and define properties and events for it, and that is what we are going to be doing. So let's go to the textbook and see how they describe it. For an introduction, they use an ID document, an ID smart card. On your ID card you have a whole list of details, and these would be your properties. So nationality, date of birth, number, identity number, photo, name and surname, and that is one instance of the ID class. What can we do with it? Well, you can use it to scan, to transfer data onto it, and present it to verify the person's identity. So those are things. So we call them attributes, and attributes are like the properties, and the behavior is like the events. So your attributes will be your name, your surname, and so on, and the behavior is what that card can be used for. There's some new words here, so memorize this. This is nice theory questions they like to ask you. Attributes is the data fields of the class, okay, and the behavior is the code that provides interaction with the attributes. So attributes are like your variables, and the behavior is like your methods. And an instance of a class is actually, for instance, you as a person will have an ID book, so you are an instance of the ID of that class, that everybody has an ID book, and that's what an instance of a class is basically. You as a member of an RT student in grade 12, if we had the class called RT grade 12, then you as a student, you are an instance of that class called grade 12 RT. And when you declare an instance of a class, you're saying, well, that thing or that item or that person is going to have those attributes and that behavior. So attributes and behavior, in other words, the data fields or the variables and the methods together form one class, and if you are belonging to it, then you are an instance of the class. Here's an official definition here: a data type that describes the attributes and behavior of the object to be modeled electronically. And this word encapsulation just means grouping of attributes and behavior in one entity. It's just basically the method that we use to create classes. Okay, so here's some more definitions. It's the same as the ones over there, so study that for your theory exams. Now, we can reuse code. It helps us to reuse code, and we can create independent programs that are not influenced by other parts of the program, and also improves the integrity of the program and its data, because the data is put in a private section. So we're going to learn how to declare classes and use the methods and instantiate a class, in other words, get a variable and make it belong to that class. and then actually use that the classes methods in the program. How to actually define a class, how to get started. Well, they've got the layout here, how you're supposed to do it, but practice is always the best thing. So we will do it in practice. You can read through that, the declaring a class, and we're going to do it in an activity on page 58 now. Okay, on page 58 we can actually go and create a class unit file. So this is page 58 in your textbook for grade 12. Okay, and let's assume, okay, now there's the scenario here, or case study. Imagine you're going to build a web application for buying and selling second-hand phones, and you're going to have hundreds of users selling and buying phones at any time. So your phone is the same as an ID card, so each phone has information about it that you want to record. So in other words, the phone's brand, the phone's model number, the seller's price, the date of purchase. And how are you going to store this information? Well, we can make a class called tPhone. Classes, this is a weird thing. Classes always begin with the word T. If you look carefully over here in the code, label 1 belongs to the class T label. Panel 1 belongs to the class T panel, and so on. Form 1 belongs to the class T form. You see there's form 1 belonging to the class T form 1. Label 4 belongs to the class T label, and T edit, and you have all these other types. So these, another word, the T stands for type. So in other words, a class is like a type that is being defined. So we're going to make our own class called tPhone, and it's going to have the following properties, or should we say data items or attributes or variables even: brand, model, owner, purchase date, and price. And each variable is going to have its own data type. Okay, so we'll have the data types there. Now, so we're going to have methods to work out the age of the phone, because from the purchase date. Okay, we might have some other methods as well. And we're going to have an object, so we'll have many phones, so each phone is going to be an object of that type, tPhone. Remember the word object? Like for instance, over here we have object EDT price belongs to the class T edit. Object label 2 belongs to the class T label. Object BTN save belongs to the class T button. So that's what we're going to do. We're going to declare objects belonging to the class of tPhone. Once we've defined our class, or in other words, written it, then we can have more than one objects belonging to it, or even an array of objects. Each of these objects will have a unique set of information to represent a phone. So each object can have its own brand, its own model, its own owner, its own purchase date, and its own price. Right, so that's just background. Now the actual creating the actual file. So what you're going to do is you're going to open this program in the Sell My Phone folder in chapter 2 of your data files. So we are going to now write our own class for this program. So we open the program, fine, and then we see the interface, and then we see a string grid component, but don't worry about it. We're not going to worry about it now. Worry about the string grid later. We're going to go to File, New, and Unit. File, New, Unit. This is how you're going to create your class. File, New, Unit. So there it says Unit 1. But now we must save it straight away to, what are we going to call it? We're going to call it Phone Class. I'm going to save it in the same folder where our Sell My Phone program is. So we go straight away and go File, Save As, and then we make sure we're in the right folder. Okay, well, we are in, and then we're going to call it here Phone Class. Phone Class, and click Save. Now we've done that, and you'll see Phone Class is written there in the tab. That means that's what it's called on the hard drive. But and it's also given the name there, unit phone class. Okay, so that's fine. Now you'll see that there is interfaces, implementation, and end. Okay, and before we go on further, let's have a look at our what we call a this is a class diagram, and you'll get asked in a theory question to either create a class diagram or examine a class diagram and discuss it and answer questions about it. So basically how you draw a class diagram is this. You have the class name there, phone class, and then you have attributes and methods. Now attributes are all the variables, like I told you before, that we're going to use in the class. In this case it's brand, which is a string, and the model, the owner, the purchase date, and the price. And the methods are what are we going to do with those attributes? Well, first of all, we've got to have a create constructor. It's actually shouldn't be called procedure, it's called constructor create. And that means we call that constructor create whenever we want to instantiate or otherwise say, okay, this phone must belong to that object, to that class. When we take an object and want it to belong to a class, we have to use a create method. And the create method can either have parameters in it or not. And then we have functions and procedures like we've done before. We've written functions and procedures now, and we know how to do that. So we'll have different functions. There's a function to get the price of the phone. There's a procedure to actually set the price. There's a function to calculate the age, which returns an integer. There's a function toString, which will return a string. So there we have the three things: identity, the actual attributes, and then the methods. In other words, the methods is the behavior, and this encapsulation is just basically a word to describe, okay, we've got everything in one. Right, now we're going to add code to our new unit over here that we just saved. Well, in the interface, we press enter, and we've got to include a users section. So I like to always call sysutils and dialogues and math. I always put those three in just in case. Now dialogue is and sysutils and dialogues are included in uses in the main program, and sysutils is also included. Math is in case we need to do anything like random range and so on. So in the users section we have our other programs that we want to use. So remember, we've got two tabs now. We've got the tab for our main program. This is our main program, and then this is the class that we are defining. First thing we do is go to the users section, and under users then we're going to put in the word type. Okay, type, because remember we have type over here too, don't we? So type, and then in type we're going to put in our class. We're going to say, okay, I want tphone to be equal to a class. Okay, fine. Tphone equals class. Oops. And then press enter. When you press enter, there'll be an end. You keep that end there. You don't let it go away. And then we're going to put private and public. Private, because we're going to list things with private and list things under public. So typically what we normally do is we put our attributes, in other words, the variables or the data items, isn't the same, a lot of words for the same thing, put them under private, and then in the public we put all our methods. That's what we typically do. I'm not saying it's set in stone, but that is what we do. And yeah, basically we've got the skeleton code for our class, so we can save. And its best idea is to run, so to make sure that it does actually, there's no spelling mistakes and so on so far. And when you run, if you do file save all, it's going to save the phone class and the main program. Okay. Now the other thing that we have to do is you have to make sure that the main program can use phone class. So we go to this unit name over here, phone class, Control C, and inside the users section over here, Alright, it's already been put there. Phone class must be put there, so it is there already. Okay, so now let's go on to the next thing. Right, so attributes or data on the private section, because you don't want other units to get access to them, and that stays protected. Now we're going to add these variables to our private section. They're called variables, okay? Variables. Now what normally happens actually, to differentiate these variables from other variables that we might use in our class, put an F in front of it for field. F purchase date, F price, F owner, F model, F brand, so that we know that they are different, they are being used only as the class. The class itself's variables. They act like variables, yep. And we call them attributes or data items. Now, declaring the methods. So we've got all these things here: brand, model, owner, purchase date, price. Fine, done. Now we have to worry about the methods. It's a code that actually brings behavior. We use the methods together with our private fields or attributes or these variables with the F in front of them. Under public, we can declare methods that will use those. The first thing we need is a constructor. A constructor will instantiate an object. In other words, allow an object to belong to a class. And an object is like a variable itself. In fact, we're going to declare variables in our main program to belong to that class. Later on, we'll declare a variable here and say it's going to belong to the phone class, called tphone. See that word tphone? You remember that word? That's our class name, and we're going to basically say my phone, something like that, colon tphone, and that means that this variable must belong to that class tphone, just like we have any other variables belonging to a different class or data type. T for type, eh? So as you can see, making your own class is like making your own data type in a way. Now we have to go and declare methods, and that's a tricky part. Just imagine it just like we did in grade 11 work we did up to now, declaring your own procedures and functions, just the same, except for the fact that we're going to use a constructor as well. Constructor create, basically described here that a phone object needs to be created or constructed for the user to interact with. Special method only used once and started with the Delphi keyword constructor is used to instantiate the object. This method is called create to give a clear sense of its purpose. And then we declare methods that will act on the attributes, and there's an example. So after we've done constructor create, we need to worry about, okay, we want to get the price in order to view it before making charge changes, or if you want to set the price, if you want to lower the price or make it higher, and then if you want to find out the age of the phone. So these are the things we can do with the data items. And maybe you want to print out your phone details, so we use toString to return the values all stored in the attributes. A function called toString, so we can use procedures and functions to do that. Right, and here they are. Okay, so on the left hand side and the right hand side, we have in here, I don't know why they say syntax, and that's a bit confusing, but on the right hand side here we have our method headings, so we're going to use those. I'm going to copy them and put them into my program code under public. So we have a constructor create, we have a function called get price, we have a procedure called set price, we have a function called toString, and let's look at these. Just like in grade 11 when you made your own methods, except for this constructor create, The function returns a real number. We'll call that real, not double. And the procedure set price will receive a real data type. The function calculate age will return an integer. The procedure toString is going to return a string. So these are the headers of methods that we are going to write. Okay, now, and we know how to do implementation. Hey, we just Control-Shift-C, highlight and Control-Shift-C. Okay, so as you can see, we've declared, and now we're going to do our implementation. So this is just showing you what we're going to do next. So I'm going to do that next. Highlight all of this and Control-Shift-C. And now we have every single method has been implemented. In other words, so it's just ready for us to write code in it. And the secret is, what code do we write and how are we going to do that? Okay, so let's go and file save all to make sure everything's working, the syntax is correct so far, and everything is fine, and we did file save all. Now we're going to go to the actual writing of the code. First of all, constructors. There's a default constructor that Delphi has assigned, and there's one that can have parameters. Okay, the default constructor will basically, you know, it just says, okay, you belong to that class. But if you want to have a constructor with parameters and you want the default constructor as well, then we have to use an overload word, the word overload. So this word overload has to be included inside the, if you want to have two constructor creates, should I say, constructor create. But that's actually just getting too confusing. So we're not going to use constructor create over here. Okay, well, let's not use that one. We're going to use a different one. Constructor create we're going to use with parameters. So when you want to define that a phone belongs to this class T phone, you want to go and get all its details and put it in, you know, get all the details and put it in. So our constructor create is going to have these variables inside a parameter list. Now, obviously, this is going to be confusing for you now, but I'm going to explain it in a minute. Just give me, I'm just trying to get this. There's a lot of things coming in here. And the constructor acts like a procedure. Yeah, you could have just written the word procedure. But actually, the constructor acts like a procedure. It receives all of these things. It's a lot of things to receive, isn't it? It's the brand, the model, the owner, the purchase date, and the price. So I deleted the other constructor create in the implementation part here, because I want to use this constructor create with all of these parameters. In other words, when we say, okay, this phone belongs to this class T phone, we want to set all these private fields here to have unique values. And the values are going to be here in this list of parameters. A brand will be stored, whatever brand is, it's going to go into the variable F brand. Whatever model is, it's going to go into the variable F model. Whatever owner is going to go into this variable F owner over here. Whatever purchase date is going to go to F purchase date over there. Whatever this price is, it's going to go into F price over there. Okay, and this must be a real number as well. Let's not use double, we'll use real. We know what real is, decimal points. Okay, so now I've got this constructor create. You see that the others have been implemented. I deleted the implementation of that other create, so I've got to go and highlight this and Control-Shift-C. Now, inside here, I'm going to say F brand equals what? F model. Where did I get F model from? Equals. F owner. Where did I get that from? Equals. F purchase date. Where did I get that from? Equals. F price. Equals. This is what we do in constructor. We set the private fields. You see this 1, 2, 3, 4, 5, all with F in front of the words. F brand, F model, F owner, F purchase date, F price. So what am I going to do? Simple. F brand is going to be equal to the brand coming in here. And it's the same data type, so I can do it. F model be equal to model. Oops. That coming in from this parameter list. F owner will be equal to owner. F purchase date will equal to purchase date. And F price will be equal to price. And that's it. We've got the private fields over here being equal to whatever comes into our constructor create. And like I said, even though it's called constructor, you might as well just call it procedure, because it actually acts just like a procedure. So don't get afraid when you see the word constructor. We're just using it as a procedure. And don't worry about this overload method. You don't have to know that for exams. Right, so now we're going to do the other methods. So we've done the constructor, okay? Don't worry about all of that, okay? We've done it right over here. It's perfectly 100% correct there, okay? Now we're going to move on to the other methods over here. Get price. Oh, there's a get price method. What is get price method? Where is it? There it is. Get price. A real method. That's going to return the purchase price. So we got the get price over here, and we say result equals F purchase price. Simple as that. That's what get price is going to do. It says result equals the purchase price. And we're done. And then we have the next one, and that is called set price. Set price is going to set the price to a value that's coming in to this procedure. The procedure called set price has a real number coming in, and we're going to change F price and make it equal to the price that comes in here. Just like that. Now you must look at these two carefully. Function is called get, procedure is called set. Now in an exam they might ask you to write a set method. Then you must know you've got to write a procedure. Or they might ask you to call a get method, and then you must know you're going to write a function. Okay, remember that. That's something important to remember, that functions are get methods and procedures are set methods. And then the last, what else do we have? So set price, okay. We have calculate age. Now our calculate age is going to return an integer where we have to go and find the number of days. And they've got the code here for it, so we might as well just use it, you know, because it's quite tricky to figure out the age of a person. So I'm not here to test. We're not here to learn about that, but it's good to know. Calculate age. They give us the code for that. We just need to know that we're working on the F purchase date, the private field called F purchase date. See, I put F's in front of them so we know the difference between them. Now is a function that returns today's date, or we could have even used the word date, but now would be fine. And they've got a variable called num days, which is rounding that, and then num days divided by 365 basically gives you the age in years, and div means we want to return it as an integer, so there it is. So guys, study this. This is quite a cool thing to know about. You might be asked to find the age of something using a date data type, because if purchase is date is a date time data type. So that's quite a useful bit of knowledge there. And then of course toString returns a string representing the state of the object. So it's actually all the fields of your class. Basically just returning all the fields as strings. So you just say result equals, and then you format a string, and using the F private fields, yeah, that line break and so on. Purchase date, form date, okay, DD, what? Format date time with how many D? DDD, DDD, I don't know what they mean by that. Anyway, format the date time, for sending the purchase date. You can say date to string too if you want, you know. You don't have to do this. You can say date to string. Should also work perfectly fine. And then this is a hash 13, not a line break, hash 13, and then you get the price. So brand, and normally the S line break hash 13 is good enough. So use a hash 13 is going to work as well. S line break, we'll use hash 13, okay? So S line means the string's going to go to a new line. So you'll have the brand, and then F brand, the model, then F model, the owner, then F owner. And where do these F variables come from? They're here, they're the private fields. So this is what a toString typically does. It returns a string, it's a function, okay, return something, always remember that, function returns something, a string, and then you can go and compile your string, say result equals that whole thing compiled together. It's a big string. And what we've done here with the price is, yeah, a different way of formatting. Let's just say float to string F, R price, F price, because we know it's real, comma FF currency, comma 8, comma 2. So we can do that. Is much more understandable for you. So all the private fields, F brand, F model, F owner, F purchase date, F currency, are all joined together in a string so that we can display it when we call the function toString. So we're going to use all of these methods that we've written here in the main program. And now you're going to complete the class, and tomorrow we will use it.